Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Type in your question, hit submit, and we'll get to those at the end of the session. If you're watching along on YouTube, just feel free to use the live chat if you're watching live. Otherwise, you can feel free to leave a comment as well after the fact. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 11 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic equipment. Then before that, it was 8 years at Subaru. So I worked in a dealership and over time just became that default diag guy in the shop. I'm sure there's a few of you watching right now as well. So I just always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bin. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years underhood experience for me. So our topic today is continuing on with this new series we started a couple weeks ago of OEM-specific training. Now, as I said, I used to work for Subaru, right? So I know when you work on the same make all the time, you come up with these things that are, if it's this, it's this. When you have some sort of a failure or malfunction, after a while you tend to check the same things first, and you learn over time, what those idiosyncrasies are for that particular brand. So that's what we're going to try and do with this series, is help you. Maybe you don't work on Toyotas all that often, and maybe one comes into your shop and it displays one of these issues, or one of these oddball things, then that might help you. So that's the point of this, is we're trying to help as many of you as we can with these specific makes and the specific weird idiosyncrasies that some of them may have. So today we are on our Asian make for this batch, and that would be Toyota. So we did it based on North American sales. So Ford was our domestic, and then Toyota is our Asian, and then a couple weeks we'll be doing BMW in this first batch here, and then we'll continue on throughout the year. We're going to try and get to pretty much all of them by the end of the year. So with that, let's start with some history. Where did it all begin? And it began quite a while ago. So in September of 1933, Toyota was established by Kiichiro Toyoda. Notice how it's spelled a little bit differently. That's not a misprint. His name is spelled Toyda. So the name was actually changed a little bit later after they incorporated in 1937. It was changed for good luck. So the story with that goes, 8 is a lucky number in Japanese culture. And if you were to write out Toyoda with a D, it takes more characters, or when you're writing out Japanese characters, it takes more strokes than Toyota with a T. So the Toyota with a T actually takes 8 strokes to make in Japanese letters. So that was considered good luck. So they changed the name to Toyota for that reason. Began mainly pre-war, pre-World War II, building mainly trucks. A lot of trucks were, used in World War II as well. Post World War II, though, they started building passenger cars as well. So, in 1955, the Toyopet Crown was Toyota's first fully designed and built automobile that came out. So, other times they had used other manufacturers' designs, or sometimes it was just kind of a car body on a truck frame, that sort of thing. So this was their first ground up designed and built automobile. So as I said, August 1955. And since then, Toyota's become the largest auto manufacturer in the world by volume. So they manufacture over 10 million vehicles every year. And that's, of course, worldwide. They have manufacturing facilities worldwide. And of course, they sell them worldwide as well. A couple other things that Toyota is quite famous for, and a lot of it has to do with automotive manufacturing, is, of course, the Toyota Way, which is what they call their corporate policies. So part of those corporate policies are continuous improvement and respect for people. Now, I know we talk about this at Snap-on a lot, because those are two of our core values as well. Because I also, not only do I train you all, I also train our new employees as well. So we walk them through that. Rapid continuous improvement is one of our core things. And the Toyota production system as well gets placed in. We adopted a lot of that as well here at Snap-on. So it's a lean production. So that means we don't have too much of anything in stock, and we just kind of, everything rolls through and just in time production, which a lot of manufacturers over the years have adopted those principles with Toyota. So that's another thing that they have given to us as Toyota has given those to the world. So, long-standing company. So very, as we may know, a reliable vehicle. So this one was a bit of a challenge to find some commonality, some common issues with them. But as we go through, you'll see what the data has to say. So first off, top models. So when it comes to sales volume, as I said, this is North American sales, and this is over 10 years, 2013 to 2023. So the RAV4 overall in those 10 years was the best-selling model, followed by the Camry, Corolla, Tacoma, etc., all the way down through the Avalon at 390,000 over 10 years. 20 million vehicles just in North America sold in those 10 years. So that's well, 2 million a year if you want to average it out. So uh, as we said, quite high sales volume for them. So I decided to pick out a few representative vehicles from that list. So a 2019 RAV4 was kind of the peak in the last over that 10 years. The peak of its sales for the RAV4 was 2019. So that 2019 RAV4 was the fifth generation of the RAV4. Offers two engines, count them, two engines. So a 2.5 liter naturally aspirated engine, which they use in a lot of other vehicles as well, and then a 2.5 liter hybrid engine as well. And then it's an 8-speed automatic transmission on the naturally aspirated vehicle. And of course, the hybrid vehicle uses a kind of a CVT, eCVT type drivetrain for that because of how the hybrid vehicle works. And then another representative, good representative, was the 2015 model year Camry. So that was a fifth generation wide body style. So it had a narrow body and a wider body style of the Camry over the years. And it was also a mid-generation refresh. So it was a fifth generation. We're about halfway through the generation. And they refreshed, the front clip, taillights, that sort of thing. Offers that same 2.5 liter naturally aspirated engine, and also the 2.5 liter hybrid engine that is in the RAV4. And also they use the 3.5 liter V6 naturally aspirated engine that they use in a lot of vehicles as well. So one thing that you will notice as we talk through this, and most manufacturers, I think, kind of try and follow this rule anyways. It's kind of with that lean manufacturing principle where they have a few different engines and they use them in a lot of different things. Um, we'll get to other companies where they'll use the same platform for multiple vehicles. They use the same engine for multiple vehicles. So this is fairly common. Um, there's not a wide selection of engines when it comes to Toyota. You're going to see maybe 4 or 5 different engines and then just some variants on them. 6-speed automatic transmission on the non-hybrids, and of course the eCVT in the hybrid vehicle. Also interesting, this model year range, 2015 and 2016, it was the most American-made car. So 75% of the parts that were in the Camrys were made in America or sourced from America. Well, I guess made in America would be sourced from America, yes, and built in America because they have multiple factories. They actually share a factory with Subaru in Indiana as well to make Camrys. So 75% of the parts in the 2015 and 16 Camry were the largest amount of American-made parts in any vehicle. That includes Ford, Chevy, Dodge. So I just thought that was an interesting little tidbit that came up as well. And then another example, it wasn't the highest up on the list, but still with 1 million vehicles sold over the 10 years, or roughly 1 million vehicles, the 2013 Prius. Because if you know Toyota, you know they are big on hybrids. They were one of the early adopters to working on hybrid technology, and they've just been progressing throughout. So the 2013 Prius was a high watermark for that kind of era as well. So that was a third generation Prius. As I said, they've been making them for quite some time. There's a 1.5 liter hybrid engine, and of course a 1.8 liter hybrid engine, and an eCVT transmission, as all of the hybrid vehicles have. And as I said, in 2013, that was their highest North American sales volume year. So it's slowly gone down, and I think maybe some of that could be due to they started putting hybrid powertrains in other models. So you get a RAV4 hybrid, you get a Camry hybrid, Corolla hybrid, so many hybrids that they make now. They have the choice. So before with the Prius, you really only had the choice of the Prius at the time, maybe a little earlier. But so there's our representatives, and we're going to kind of look through those, look through a few different things on those when we go live in a little while. But those are our representative common vehicles. Some common issues. As I said in the intro, it's they're fairly good when it comes to having major problems. They're really reliable, as you may know. But yeah, what I did find digging through the information, so many evap issues on there. You're going to find a ton of evap codes, and that's, I think, fairly standard across the board on pretty much any manufacturer. You're going to get a ton of evap issues just because it's the system is I don't want to say it's complex, but there's a lot of failure points. So that could be an issue. Certain generations of hybrids, especially the early ones, had high voltage battery issues. So, as they changed chemistries and improved on the batteries, it's become less common. Misfires are very common on that 3.5 liter V6 and the 4 liter as well. A lot of coil issues on those. And as you may have heard over the years, some major recalls and campaigns have happened. Frames. I remember talking to people so many times about doing those the pickup truck frames. To have to swap the whole body off to swap the frame, and there was just stacks of frames out and back. And of course the accelerator pedals too, with the issue with actually really the carpet, right? Kind of getting on the accelerator pedal, and I suppose they may have had some accelerator pedal issues to boot, but I believe the actual fix for that was the floor mat, and they kind of pinned it down, and they didn't have those problems anymore. But that was obviously global news when that happened. So, have had some major recalls in the past, but overall, pretty reliable car. Common codes. This was really interesting. So if we look at the top 10 most common codes based on our list of over 3,000 common codes in North America, if we filtered it down by Toyota, and you'll see 8 out of the top 10 are this P1604 amongst various different engines, right? 2.5 liter, 1.8 liter, 3.5 liter, all of them. So it's called a startability malfunction. So the definition of what this means is it didn't start successfully, or it started installed, or something of that nature. The very first time it didn't start. Now, talking to Toyota technicians who've experienced this, and they say pretty much any vehicle, when it throws codes dealing with the engine, this usually is there too. So they called it a Me Too code. Right. So this shows up a lot. And rule of thumb is don't bother checking that one until you've checked the other ones around it that got set off at the same time, because it's probably more likely that. And then down here at the very bottom, we have a lean code. So a lot of startability malfunctions, like I said, because that code gets thrown a lot in conjunction with other codes. So I decided let's take it a step further and filter it down then, and filter out those 1604 codes as well, so we can get down to see what other problems we may actually have with the vehicle. And I'm seeing a lot of lean codes. A lot. Also notice it's on the same engine, right? You'll notice that commonality between the 1.8 liter. Apparently, that is a pretty common lean code problem. On the hybrid, you get a high voltage battery malfunction. That makes sense on a 2007 Prius. That's the older one. AF sensor, oxygen sensor. So, and it looks like a lot of it's focused on those 1.8 liters. So fairly common to get the lean conditions on those. When you get to the 3.5 liters, like I said, a lot of misfires, coils, and that sort of thing. So using real world data from real people working on real cars can help us kind of decide, what is actually some of the common issues with these vehicles. Some OEM specific features, and one that really sticks out in my mind is the engine. So mid 2000s or so, maybe in the teens, I guess. they started doing direct injection engines, right? And if you know anything about direct injection engines, one of the major problems with those is you get carbon on the valves because the direct injector injects directly into the combustion chamber, not the intake. So what they do with these D4S engine is it'll do both. So it has gas that goes in direct injected, and it also has a fuel injector, a regular fuel injector on the top that sprays inside the intake manifold and solves that problem. Now, don't be fooled. The reason that that top injector is there is not just to keep the valves clean. It does burn the fuel as well. So it allows them to, really make the mixture specific using both of those injectors and that technique. So I thought that was kind of an interesting thing because I don't really know of anybody else who does it that way, where they have two sets of injectors on the engine. So to that point, if you are diagnosing a fuel problem or a misfire or something like that, just be aware, double the fuel injectors on this vehicle. So just be aware of that may be something you need to investigate. You may have to look at the high pressure direct injector or the lower pressure fuel injector. So just kind of an odd duck there. Now we're going to get to a section that I call tips from a tech. So these are the things that are maybe you might not find this in service information. Some of it you might. But a lot of these are the experience of the technician. So I actually was with a former Toyota tech this past weekend. He's one of our diagnostic sales rep, Elliot Levy. He's out in Denver area. And he was a former tech at Toyota. So between him and a couple of his buddies who still work there, they came up with a few interesting, little weird, anomalies with Toyota. So first one is 9 to 14-ish model year. I'm sure it could be on kind of either side of that. But Corolla that got in a collision, a front-end collision. And when they put it back together, after the body shop had it and they put it back together, well, you look at the cluster and the cluster be going crazy. Lights would be flashing, needles would be moving, and just not doing normal speedometer, tachometer things. It would just be kind of going crazy, going wild. And what they come to find out was, and this is not just one vehicle, this was many vehicles this happened to. I don't know if maybe it was just one body shop, but what would happen is they would paint the bumper first, right? Or you paint the metal underneath the bumper fascia, and then they would put the grounds on. So the grounds here on these corners here, they're behind the headlights, kind of down on the unibody bumper area. They'd spray that area, then put the grounds on, and then wonder why they had ground problems. So it would introduce electrical problems. Easy enough to fix, pop them off, take the paint off, and then make sure it gets a good metal to stick to, and then there you go. So that was kind of an interesting one off the bat. Next one, second gen Tacomas. So in the second gen Tacomas, they had fuel pump issues, and what it boiled down to usually on the fuel pump was they were going to have corrosion where the fuel pump relay goes. So if you pulled the relay out, you can see corrosion. Also, somewhere within the line, there might be some corrosion as well. I also saw, because I researched it a little bit as well, some overheated wires, melted connectors, things of that nature. So you might find that with a fuel pump relay, or you might find it back at the fuel pump as well. So we can see there's the ground, and then there's also a resistor that I saw could be an issue there as well. So that would cause the vehicle to die or drop pressure while operating going down the road. So that's second gen Tacomas, and it's fairly specific to that particular model. Another one, this one was interesting. This one actually has a bulletin on it. So 14 to 24 runners. If you were to put aftermarket LED headlight bulbs in there, like I'm sure some people do, it can cause issues. So much so that they actually came out with a bulletin. It says, 2014 to 2020 model year 4Runners may experience the ABS light on with DTC, 1, 2, 3, 4 different DTCs, stored current in the ABS system. So ABS light will turn on. It may not have the codes either. So the first thing it says, well, inspect the ABS connector for signs of damage. If it's okay, the next thing they want you to do is break out a scope and look at some of the lines on there. So you're going to hook up the scope with the lights on and with the lights off on the power or the ground. Yeah, I believe it was the ground. I'd have to read through the bullet again. But you would go through and connect it how it says, and with the lights on, if you get a lot of noise like this, look at that noisy pattern. So if you see noise like this, then that means the LED light bulbs are probably the culprit. They suggest to replace with factory bulbs and see if it goes away. If it goes away, there's your problem. So causing all sorts of EMF in the lines in the ground side, so that can cause these ABS issues or ABS codes, which aren't actually ABS issues. It's actually interference from the aftermarket LED. And then this last one here was really interesting, and I'm not sure I've ever seen this anywhere else. But this is an inspection procedure for misfires. So they go through the usual suspects, check this, check that, check for fuel, check for spark and all that, check for different things. And then all the way down at the very bottom, the last one, an extremely imbalanced drive wheel, which causes body vibration, may cause misfire DTC detection. So if I'm fighting a misfire on a Toyota, and from what Elliot told me, it was on Avalon's. But then as I looked through it and looked at other models, this is listed on every single model for a misfire code on a vehicle, on a Toyota. So if you have imbalanced drive wheels, it will shake the drivetrain enough where it throws the crank sensor off. And then the crank sensor thinks it's detecting a misfire when actually it's the vibration in the drivetrain. So I thought that was kind of wild. And like I said, I've never really seen that on any other manufacturers. So I'd say that's probably pretty unique in there. All right, let's talk about a few OEM specific functions with the scan tool as well. So not a ton out there, not as much as say like when we looked at Ford last time, there was a lot of specific tests for Ford. But we do work in conjunction with Toyota on their factory tools. So we do have, for all intents and purposes, all the factory functions that you would need. One big thing that a couple other manufacturers have, but the first one we saw it on was Toyota, was multiple freeze frame. So what it'll do over here on the side here, you see how I got a code, and then next to it we got this little film strip. If you were to click that film strip, it allows you to go through blocks of freeze frames. So we have they're on I believe it's half-second increments. One is just past the code, one is when the code sets, and then 1, 2, and 3 segments back. It's either half a second or a second. I don't recall again off the top of my head, but I will take multiple freeze frames of that problem. So it's just always taking snapshots, and when it finally throws a code, it will give you the code when it's set, the freeze frame there, a freeze frame right after, a freeze frame right before, and then 2 other segments before that. So that is very helpful when it comes to, well, what happened? Did one of these data points drop out at some point? And then also an automated evap test. So as we saw, there's some evap problems on these. And another unique thing, fairly unique thing that they have is they have a leak detection pump on the vehicle that will not trigger the evap test until 5-hour cold soak. So the vehicle has to be off for 5 hours before it's going to run the evap test. So you can actually force it with the scan tool. You can force it to bypass that cold soak time and then just do the evap test right away for verification purposes. After I've done some evap work, what it'll do is it'll run the vacuum pump, it pulls vacuum, checks for leaks, that sort of thing that it normally would do in the course of doing the evap monitor. So that's engine-related tests. Multiple freeze frame again, so we would see multiple different freeze frame data points as we go across. And then as far as transmission-related tests, I hadn't really seen this one anywhere either, was automatic transmission code registration, read and write. So when you replace the transmission on many different Toyotas, they want you to, as a compensation code for that. So it's similar to like maybe a fuel injector compensation code, something like that. The TCM needs to know what solenoids are in there, how it's going to operate, how it's going to shift. So there's different registration codes that match the transmission to the module. So you need to do that anytime you do any transmission work, change transmission, TCM, that sort of thing. So you actually go through, you'll read the old compensation code, and then it'll store it to the tool, and then when you put the new one in, it'll write the compensation code back in. So it's kind of like a copy and paste with that. All right, so let's go live on the tool and look at a couple things. First, we'll look at a couple of these scan tool functions. Let's go in and we'll pull up, let's say, the Camry first. Okay. So let's go into engine, and we'll see we got a lot of options in engine, more than just codes data. There's that freeze frame function, right? So if we go in there, you can see there's that film strip over there, and you can cycle through the different freeze frames. So that's brought right to the front. As far as functional tests, that's going to be your on-off bidirectional control type things. Check mode, what that is it allows 2 trip DTCs to be set in 1 trip. So that's pretty helpful. It tightens the DTC detection criteria, so the DTCs will set easier. So if I'm trying to do a road test and trying to duplicate a customer concern, that's one thing it'll do. It'll put it in check mode. System tests is going to be your evap check. So that's that automatic test that I said. It's going to activate the purge valve, vent valve, and vacuum pump to draw and release vacuum. It's going to be confirmed by observing vapor pressure, so that you'll see the pressure drop and hopefully not rise when it's pulling vacuum out. You can do it automatically or manually step through each step. VIN read and write, generic functions, which would be just bringing us a generic OBD2, so that is not anything different with that. Let me see if this one's got the compensation code in here. So the transmission, yeah, AT code registration read and write. So the function is used to input a compensation code and initialize the ECU after an AT assembly or ECU has been replaced. So you would go through there, it's going to copy it, and then you paste it back in. So that's our functions. Let's actually look at some real world information on this as well, sure track information. All right, so I first put it in as the default, the 4-cylinder or the standard 4-cylinder, it's in there. Very common engine and vehicle combination, 430,138 repair orders that we have for this. So pretty safe to say we can be pretty confident in this. This covers quite a wide gamut. As usual, you would expect pads and rotors, wheels, battery, spark plugs. None of this really sticks out that much. Maybe tire pressure sensors a little high on that list. I don't think so though. That's a pretty common, looks like a pretty, as we said, fairly maintenance-free vehicle. Not a lot of weird stuff popping up in there. Symptoms, noise heard from brakes, engine doesn't start, noises heard, a lot of noises, a couple oil leaks. Nothing major I'd be too concerned about that either. And then if we go over here, you can see, like I said before, evap, right? So evap. There's that 1604 Me2 code, 171 lean, brake switch, throttle position, catalyst efficiency. 1605 is a mate to the 1604, and a body B1479. What's that? Let's see. Oh, it's AC, it looks like. Let's see. What's the definition of that? Flow sensor circuit. AC flow sensor in the compressor. So a couple issues with that. 137 out of 430,000. That's not that common. But evap, incorrect purge flow, gross leak, or small leak. So a lot of the evap leaks, like we said before. Now, if I switch the engine, though, because remember, most of these things are going to follow the engine. So if I go to the 6-cylinder, you see 267,000 repairs. And now we're into misfires, misfire heaven right here. Let's see, we got coil, random misfire, coil, oxygen sensor heater, misfire. So those 6-cylinders are pretty common to misfire. Engine runs rough, number 1 symptom on that. Engine does not start, AC and op. Axle shaft, that seems kind of high up. Ignition coil, that tracks, right? Number 6 is ignition coil, considering the top 3 out of the top 4 codes are ignition coil problems, plus the rest of them are misfires. So a lot of different things on that. Let me just flip engines here again, go to the hybrid. That's going to be the hybrid model. And in that case, evap stuff again, right? And then there's the replace hybrid battery there, 97 times. Only 43,000 repairs. I mean, That's still a lot of repairs, but relatively speaking to the regular non-hybrid 4-cylinder, that's like 10% of that. So it's not nearly as common a vehicle, not nearly as common the engine. Stabilizer bar length, that's kind of interesting. You wouldn't expect to see that, I wouldn't think, that high up. But a lot of evap again, lean, misfires, pretty much your standard stuff. All right, let's the Camry. Let's pull the RAV4. It's going to have pretty similar tests in the scanner, so I don't think I need to go in there, but we'll go in and check the look here. This is the 2.5 non-hybrid, 19,000 repairs. This is 2019, right? So it's not that old. Wheels, disc brakes, tire valve stems, pressure sensors, batteries, refrigerant. That seems a little high. AC and op over there as well. So we got engine coolant bypass valve. That's odd. Evap, misfires, thermostat heater again. So we got a couple coolant problems with that. Intake valve, evap. What's this one? That's a really weird code. So weird that it doesn't even come up because it is probably a detail code. 6 times. I wonder what that one is. Let's see. So that's the non-hybrid, and then we'll go to the hybrid. Should be the W, I think. Yeah. All right, hybrid 21,000 repairs, wheels and tires, batteries. Another hybrid code, that one should be as well. Motor electronics, coolant pump, system too lean, evap. Lots of evap problems again on these hybrids, right? One more, we'll go through the Prius. And we'll see what that is. Okay. 42,000 repairs on that one, 1.5 liter. Number 1, replace the battery. Replace the hybrid. Remember how I said a lot of them had issues with the batteries. Definitely an issue with the battery. Hybrid batteries pretty high up on the list there. Engine doesn't start. Could be a hybrid battery issue, possibly. Just depends on where it's at. But then other than that, wheels, brakes, headlight bulbs. Fair number of headlight bulbs. That seems kind of high. AC refrigerant. So you can see a lot of evap problems, like I said. Some misfire problems depending on the engine. And then, of course, on the hybrid vehicles, you're going to have hybrid-specific stuff, like hybrid battery. So that is the long and the short of Toyota. So hopefully, you learned a few nuggets that you might be able to apply the next time one of these things come in. And as I said, we'll be going throughout the year doing this. So if you have any other nuggets on Toyota, feel free to comment below if you're watching this on YouTube. Also, feel free to email, text, whatever. Send me some information if you have any of those other nuggets, or for any other manufacturers as we're going to be going forward. Feel free to just use other manufacturers as well if you have some of those nuggets. So that is Toyota. Let's talk about what we're going to talk about next week. So next week, it is the semi-mysterious functional tests, special functions, and output control, amongst other things, system tests, special tests, all those different things. What's the difference between these? How do they work? What do they do? Seems that this is another one of those subjects we got from customer care, right? So we get a lot of phone calls coming in, functional tests, and some confusion as to how do I run these and what do they do? So we're going to try and dive into this a little bit and describe kind of what the differences are between them. So same time, same place, as always, every Tuesday, 6 and 9 Eastern. And then 6 p.m. Eastern class goes to YouTube. So it's youtube.com/Snap-on Diagnostics if you want to watch over there. If you are watching on YouTube, please make sure you like and subscribe. It's much appreciated. Definitely helps with the algorithm and all that. And then 9 p.m. Eastern class also goes to my Facebook page. So it's facebook.com/SnapOnJason. Go give me a follow over there. You can also send me a message on Messenger that way. And that way you could get the tips in if you have any. If you want to see any of the other topics in this series, tonight is episode number 80. 80 episodes, anywhere from ADOS through Security Link, and we cover it all. You can see it all listed up there. It's all available 24 hours a day, 7 days a week for free on our YouTube channel, youtube.com/Snap-on Diagnostics. If you hit that QR code right there, you'll be able to subscribe right away. So we got questions. Before I get to that, I also want to mention my buddy Keith. So Keith also does free diagnostic training. every Wednesday and Thursday at 7:30 Eastern, 6:30 Central. So he is on Scan Tool specific training. Wednesday it's on Zeus and Zeus Plus. Thursday it's on Apollo and Triton tools. So the first hour is going to be a lot of let's get your tool set up. Let's make sure your Wi-Fi is working. Let's make sure we talk about Altus Drive and your Snap-on profile. We're going to talk about security link, and then he goes through code to completion scenario on Fast Track Intelligent Diagnostics, tells you all about it. Then he takes about a 5-minute break, and then after that, it's all about scopes, meters, the lab scope functions on those respective tools. So it's about an hour and a half, hour and 40 minutes, give or take. And it's kind of designed to have the tool in front of you. So he goes on the screen and shows you what you should see on the screen, and you can function along on your screen as well at the same time. And you can also ask him questions. Keith's been with us for over 30 years, very knowledgeable when it comes to Snap-on diagnostics. So definitely worth your time if you want to get a little bit more out of your scale. All right, so with that, that brings us to questions. So on Zoom, if you did join late on Zoom, just make sure you use that Q&A box in order to ask your questions. Looks like we got a couple here. We got quite a bit on YouTube, so I'll get to those in a second. Tom Spina says, great seeing you. Yeah, good to see you as well. Welcome back. Glad to see you in another live session. And then Gerardo says, great job. Thank you very much. Appreciate it. Hopefully you guys are digging this content on the vehicle specific stuff. It's nice to be able to stick to one brand per night. Let's see. So let's look at YouTube. So Lobo says, hi, Jason and everybody. Welcome. Thank you. Chris McConnon says hello. Nick is saying hello from the UK. I know it's very late there, and also late for Chris in Ireland. So thank you for joining. Let's see. Nick, also, little fun fact here, I guess. So with the help of the Japanese government in the 1940s, the first hybrid vehicle was designed back then. So that's kind of cool. Let's see. Matt says on his wife's Tundra, 5.7 liter. He installed HID lights, high and low beams, and no issues. Used the Zeus to make sure nothing went crazy. So that's great. And it was HIDs, not LEDs. So I think it's the LEDs that are the issue with those, Matt. Not the HIDs so much, because I think that, based on how they operate. Minus 40 temps out there too in South Dakota cause a lot of issues with tire monitor pressuring sensors. Yeah. I mean, 40 below, I would definitely see that. It gets bad enough when it's 20 degrees up here in New England. So I can imagine you definitely have some tire pressure sensors there as well. Let's see. Nick also says shock absorber problems on the Yaris are very noisy. So good to know. There's another thing. So it must be fairly common on those. Lobo says, thanks for the great training. Appreciate that. And Colonel Buckshot says good info as well. So thank you for all of the quotes and comments. And Bob says, thanks for the great info on Zoom as well. Thank you very much, everyone, for chiming in and tuning in. With that, I think that's my time. So I'd like to thank you very much for spending a little bit of time out of your day, spending a little bit of time with me. Hopefully we learned some tips and tricks and nuggets on Toyotas. As I said, they're fairly reliable, but they do have their own quirks. Every manufacturer, I think you'll agree, will have their own little quirks, and we'll get through those as we go throughout the year. So thanks for tuning in. Thanks for watching. Enjoy the rest of your week. Enjoy your weekend. With that, have a good night and take care.